For this story proof, we're asked to give a story for the following identity. Let's consider the right side first. So this expression here, 2n choose n, tells us the number of ways to select n items out of 2n. To select n items out of 2n. Now, how does the left side equate? Well, let's do the following. Let's take our 2n objects. So let's say we have our 2n objects here. And let's break them into two groups. So here we'll have group 1, and here is our group 2. So this is group 1, group 2. Now notice that each of these has size n. So this is size n, this is size n. So notice that one possible way of selecting n items out of these two groups is just to select everything from group 1. So all n items come from group 1. How many ways are there to do that? N choose n. So out of the n items in group 1, select all of them. Well, another way to select n items out of these two groups is to select n minus 1 items out of the first group. There are n choose n minus 1 ways to do so, and then select 1 item out of the second group. Another way to select n items out of these 2n is to select n minus 2 items from the first group and select 2 items from the second group. And this can be continued all the way until we select 1 item from the first group and n minus 1 item from the second group, and until we select nothing. So we don't select anything from the first group. Everything is selected, all the n items are selected from the second group. So in summation notation, we can write this as k equaling from 0 to n, n choose k times n choose n minus k. So when k is 0, we have n choose 0, n choose n. That's this term here. When k becomes 1, we have n choose 1, n choose n minus 1. That's this term here. All the way when k becomes n, we have n choose n, n choose 0, which is 1. So that's this term here. So all the terms in this summation are accounted for in this summation notation. Now, we know that n choose k, so n choose k is equal to n choose n minus k. So this expression here can be written as k from 0 to n choose k squared, and we have our left side of the equation.